Finding special values of sine and cosine. We can now get the two of the 6 trigonometric functions, which are sine and cosine. We are asked to find sine and cosine values of pi over 6 radians. We know that the whole circle is equal to 2 pi radians. Therefore, pi over 6 radians is the whole circle divided into 12 parts. Then we convert it into degrees, which is 30 degrees. Draw the right triangle in the unit circle. It looks like looks like this. Theta is equal to 6 pi radians. Given that this part is the right angle of the triangle, it must be equal to 90. The remaining angle is then 60. We now have a 30-60-90 triangle. Recalling the concept of the 30-60-90 triangle, we know that the opposite 30-degree angle is 1/2 the hypotenuse, and thus 1/2. We get sine pi over 6, which is equal to opposite over hypotenuse. Opposite over hypotenuse is equal to sine theta. We know that the hypotenuse is 1, while the opposite side of 30 is 1/2. This means that 1/2 is equal to sine pi over 6. Also, the side opposite to the 60-degree angle is 3 pi over 2. 3 pi over 2. Substituting 3 pi over 2 as the adjacent side, we can get cosine 360. Cosine theta is equal to adjacent over hypotenuse. Which means that cosine pi over 6 is equal to over 2 over 1, which then would be 3 pi over 2. Example 2. Find the sine and cosine values of pi for radians. First, 5 for radians is simply the whole circle divided into 8 different parts, where the points are pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and 7 pi over 4, and lastly 8 pi over 4. These then can be converted to pi, half pi, 2 pi or 0, and 3 pi over 2. We can convert pi over 4 to 45 degrees. This then would give us theta equal to 4 pi radians. The remaining angle would then be 90 degrees. We now have a 45-45-90 triangle. Recalling the concept of 45-45-90 triangle, we know that the opposite of the 45-degree angles is square root of 2 over 2. Thus, the value of cosine and sine for both cosine and sine, pi over 4 is both equal to 2 pi over 2.